Thank you very much. John is being a little kind. I was late in giving him the title. That's why. That's why it's wrong. But I promise you, the programming here is impeccable. It's my fault. Thank you for having me. I'm a little bit out of my depths in that I'm not a marketing person at all. I've never actually been to a marketing science gathering. It's been fascinating to hear all the different talks, and it's sort of amazing for someone who's been in the AI space my whole career. I started at a time where AI and data science, those terms weren't really being used at all, to now being at a point where there's so many AI talks in a marketing science space. I admit, I actually had some peers of mine that were doing marketing science, and they thought what I was doing was crackpot, like would never materialize to anything. So I'm glad to have the last laugh. But coming back to the topic of the day, what I'll be talking about is customer interest graphs, but really in there you'll see a lot about other methods in AI that I think are brought to bear.
We have the stage while you're talking.
Oh.
You go roam around all you want.
So I'll go a little bit into the problem definition. I'll then talk about the customer interest graph and e-commerce behavioral data. My sense is also that there's quite a few different industries represented here, but e-commerce isn't necessarily that common. So I'll talk a little bit about, in the context of e-commerce, what our biggest challenges are and why customer interests or behavioral graphs are really valuable. And then I'll use sort of a case study, one specific example. I have a demo for something that we'll be releasing later in the year that just tries to bring it to life with something real. So I think we all remember when personalization became kind of a buzzword. And what has happened over the past few years, the way I like to think about it is if the 2010s were about personalization, then the 2020s are really about individualization. So, or hyper-personalization, however we want to call it. The basic personalization that we've all come to expect is something that, frankly, consumers have come to expect. It's really a baseline expectation now. It's not a nice to have. A few statistics here. 56% of shoppers expect to find what they need in 3 clicks or less. So the importance of relevance is super critical for us. A huge challenge is bounce offs, right? You pay for that Google ad or the Meta ad. Someone here was from Meta. They land on your site, it's not relevant, they bounce off, and you just spent that money for nothing. 89% of digital businesses are investing in personalization. Those 11% will probably not be around for much longer if they're not investing in personalization, frankly. 71% of customers feel frustrated when the shopping experience is impersonal, and then 28%, we see a 28% increase in brand loyalty amongst younger generations when the communication or the outreach itself is personalized. These are some broad statistics, but I think they hold true for from most of our experiences as well. So, the screen is so big, I'm going to look at here. In e-commerce specifically, personalization really follows 99% of the time right now a pretty old-fashioned paradigm that has just become ubiquitous. And this is what we think of as recommender systems, where essentially what we're doing is looking for similarity between items and or between between the behavior of consumers in order to match, to say this consumer is like this consumer, and since they like this, then this consumer will like this. Or this product is like this product, and therefore if they like this product, they will also like this one. It's a very reductionist view of what relevance is about. Double clicking into the two key approaches, the first one being content-based filtering and the second one being collaborative filtering. Again, they're accomplishing that very simple task of matching. The first one being about the similarity in the content of the two, let's say, product listings, and the second one being about the similarity between the consumers. What I found amazing when I joined eBay. eBay is my first foray into e-commerce. Before this, I was in online travel, and before that, in financial services, and before that, in healthcare. So, did AI all the time, but bounced between industries. What I found fascinating about e-commerce is they talk about users and customers, and they say this: we have a model that predicts user-to-user similarity. But actually, when I double-clicked into it, it took me a month to figure out like the cognitive dissonance here. All they really mean is a sequence of clicks, like a sequence of products that they clicked on. That's what they're saying user, but actually a user, all it is a sequence of clicks. Now, sometimes it may have some context to it, like the user profile is an overlay, but it's not really a person per se, right? It's still really a comparison between a sequence of products to another sequence of products. And some advanced sequence models actually think of that almost the way you think of it of language or a sentence. Like they did this product, this product, this product, what's the next product they would most likely click on? I bring that up only because there's a real problem in that. That's a real reductionist view of what the customer is, and as we're thinking about personalizing for a customer, we're not going to get very far if all we do is think of a customer as a sequence of products that they click on. So deep learning can, frankly, massively, it makes it less explainable, but massively improve on the algorithmic performance of the recommendations, but it still uses the same paradigm. And what I'm showing here is from an NLP example, but the same idea holds true, where you're reducing dimensionality through what we call embeddings for various concepts. Here you can see cat, kitten, dog, houses versus man, woman, king, queen. You create the word embeddings. Nowadays you do multimodal embeddings that may include language and images. But what you essentially end up with is a vector space that allows you to compare the distance between two words or two concepts or two products. The power of deep learning has been in allowing us to really capture so many different dimensions of that product or sequence of products without really having to create any features manually. So without really needing to know what matters, just capturing all of that information and then distilling it down into these embeddings. But the approach remains the same, where what we're really doing is looking at the similarity or dissimilarity between two products. So in this case, 3 sneakers on the left. eBay spends a lot of time thinking about sneakers. I've worn the same sneakers for the past 2 years, so I'm not one of the demographics they go after. But you can see that you create the embeddings and then you use a k-nearest neighbor or similar approach to essentially compute distance. And with the near real-time or real-time systems like we have at eBay, we can do this on the fly. So a new product, they click on the product, we now have the new sequence, and we can compute that embedding and on the fly identify amongst the billions of different products what's the one that's most similar. And it does get very nuanced. Your definition of similarity can be fine-tuned or can be tuned to really specific uses where the definition of similarity matters. But as you can see on the right, we're still talking about similarity from one item to the other or from one user to the other, except the user is really just the sequence of products. It's still the same paradigm. And the problem with this paradigm is that it keeps us really locked in our own, as in the businesses, the company's own point of view, not the consumers. And this becomes, I'll show what I mean in a second, but it becomes particularly important in all of the discovery, sort of inspirational phases of the customer journey, which frankly, younger demographics are spending a lot more of their time in that part of the customer journey, and they want to be engaged in that way. So let me show what I mean. This is an example of a product taxonomy. Every e-commerce site, every retailer probably has a product taxonomy. At eBay, it's incredibly complex and convoluted because we have so many things of various kinds, right? Like someone recently sold collectible fingernails, like the fingernail clippings of some famous musicians, right? Like, where do you land that in a taxonomy? So it gets very complicated, but I wanted to show a simpler one with this idea of just looking at furniture, how you have then sort of hierarchical nature to it. But it is created from the point of view of the company and the taxonomy that makes sense and how they're selling things and how they're sourcing inventory. In the case of eBay, but this will be true for everyone, this same exact Jordan 1 sneaker, I think it's Jordan 1, shows up under 12 different leaf categories. You can see it might show up under men's apparel footwear, men's apparel athletic wear, collectibles, clothing, footwear. Some of these sell for like $106. I also run our live shopping, and the first thing we sold was $160,000 Jordan 1 sneaker. So you would call that a collectible, but it's also a sneaker. And so you might say, well, eBay's doing a terrible job with its taxonomy because it has the same, it's not mutually exclusive. But it actually is. We just don't have the concept of a sneaker, because a sneaker is something that maybe a customer has in their mind. You look at it, the first thing you say is a sneaker, but from an inventory management and inventory sourcing perspective, we don't have the concept of a sneaker. And so that's what I mean by being locked into our point of view. And you can see this really come to life on the bottom right when you're more in that discovery phase. In the search phase, where it's really about the keywords, you know exactly what you want and you land, less of an issue, because it's really less about personalization. It's more about the query, like understanding the query. But when you're trying to make recommendations, or really, frankly, anywhere else in the journey, and most of what marketers do, which is outreach, what you're trying to now do is infer relevance. And what you can see, this is real, we're doing not a very good job here, because this should be we have a different module that's for similar items that you might be interested in because they may have better prices. This is meant to inspire you to explore other things, because you want that balance between exploration and exploitation, but they're all the same product. So that's kind of not a great job. And the reason for that is because of the similarity issue. Like, how do you find something similar but not too similar, etc.? I'm just going to use this. So this challenge shows up in a lot of different contexts: upper funnel browsing, cross-selling, cross-channel personalization, personalized feeds, complementary recommendations, and then hyper-personalization. And that's the use case that I'll focus on. So the customer problem statement for this use case is customers want to be inspired, they want to shop their interests, show me diverse, fun recommendations. These are from our user research that we do. And then finally, from our own statistics, 70% of Gen Zs are saying discovery is the best part of shopping. That's one thing I can agree with Gen Zs. I know nothing about sneakers, but discovery is the fun part. Like, when you know what you want, that doesn't usually create the brand loyalty. It's more in that engagement side of the house. All right, so in this use case, what I want to show is 3 listings that fall under 3 different eBay categories. In this case, that's okay because they're different. So we have the sneaker, we have the collectible trading card, and we have a collectible poster on the right. Or maybe it's not, limited edition poster on the right. Taxonomically, totally different. In our standard recommendation models, when you're looking at one of these, you would never see the other ones, because we're following kind of our taxonomic point of view. But if you actually understood what the customer is doing and what they're interested in, and if you understood your inventory, you would see that what they might be interested in is LeBron James, and that's kind of the theme. Now, this is a really coarse example, just to make the point, but we have a ton of that in e-commerce. Ooh, 2 minutes, damn it. So, we define 63 customer behaviors, and this is what we now stream as real-time events through the customer journey and things that people are doing on our site. And of course, they consent to this, or else we don't collect it. But we collect this information, and we've distilled these down from much more granular things like your mouse is hovering over something to a more usable event. But we don't aggregate these, because what we actually want to do is understand at the level of individual events what's going on. So it'd be things like they clicked on this product, and what was the image that was shown when they clicked it, and what was the price, and et cetera, et cetera. And then we have a graph, a knowledge graph of our inventory, so all of our products. Overlaid on top of that, we have an interest graph, which is essentially how each customer is navigating across the inventory. And the inventory, each product is related to many other products according to many different kinds of relationships. So that allows us to understand what is in common to different products that is of interest to a customer. Not basing it on a definition of similarity, but basing it on what the customer is actually navigating. And so as they traverse the various neighborhoods of the graph, interests emerge, right? Or their interests emerge, because what we learn in training the model based on the historic data is neighborhoods. This is all very multidimensional, but you can think of it as neighborhoods in the graph that correspond to specific interests. Skip this one because I think we talked about deep learning models earlier, and I'll go a little bit more to the punchline. So then based on that, what we built is actually then a sequence model, which takes into account not only the products that they're looking at, there's a lot more in there because it's also all the context of that product, but the time between them. This is something that is computationally very heavy and so often not done, but there's a very big difference between you landed on a product page and you spend 20 seconds there versus you spent 2 seconds. And so that gives us clues into whether it's the strength, essentially, of their interest. So we can then create 2 bidirectional LSTMs, one for the sequence of actions and the other one for the time in between it, and we end up with what we might think of as the clickstream embedding, which then we can use as a proxy for the customer interest. This is the video. So I'm going to now I'm over time, so I'm just going to show a video to try to see how this can come together in sort of a hyper-personalized experience, and I'll speak a little bit as this is running. So what you see here is essentially trying to give an exploration experience to customers that is much more about their interest than what we predefine taxonomically. But I'm just scrolling down here. This is a screen capture, so I had to record this as a video to do the demo, but it's a screen capture of going through the app. What you'll see in a moment is when we start clicking into these interests, we can navigate the graph in any direction. We can back up too. So a big problem with personalization and standard models of personalization is it's unidirectional. As you as we learn about you and we go deeper and deeper into the personalization, you can't back out from it. You can't say, no, it's not purple shirts, it's just shirts that I was interested in. There's no way to back out. Well, what this allows them to do is to both go forward and back, and frankly, to any side as well. Let me see if I can. So what you're seeing here is, let's say, Star Wars as an example. I was going to try to fast forward to, here it is. Okay, so this is a better example. When you go into capturing the moment as an interest or a theme, by the way, what we're doing is generating the image for the banner and the text with generative AI, just as I know that's been a theme today. You can see that these interests show up. So maybe instead of just being interested in cameras, maybe it's toy cameras that you're interested in. So you add this overlay of toys. And now what you have is toy cameras. But as you're exploring, what a customer might sort of find out is it's really not just toy cameras, but it's wooden retro toy cameras that they're interested in. Now, for the demo purposes, we're showing this I'm showing the little hashtags, but in reality, it's behind the scenes. Now, the back out that I was talking about is what I'm showing here. Is you can see you could then remove the camera element and say it's actually wooden toys, retro wooden toys that they're interested in. So you sort of remove the camera. So you could because you understand the relationship between these interests, you can essentially jump from one neighborhood to the next based on what people typically do. Because it's so multidimensional, there's many, many neighborhoods that are next to each other. But you can do this in any direction. It's not just unidirectional, it's multi-directional. And of course, it's based on the way in which the customer is navigating the interest graph rather than based on our sort of predefined taxonomy. That is all I had.